Aldehydes and ketones. So, carbonyl group. Aldehydes and ketones are going to have this carbonyl functional group, so we need to get to know him. We're going to see a lot of this guy. So this is a carbon double bonded with oxygen, and the oxygen is going to have two lone pairs. The compounds we talked about in the previous chapter, most of them, the alcohols and ethers, had oxygen with single bonds. This is oxygen with a double bond to carbon. This is a polar bond. Carbon and oxygen are different enough in electronegativity that we get a polar bond. So we've got a partial negative charge on the oxygen. The oxygen's more electronegative, and it tends to draw the electron density away from the carbon. The carbon is left with a partial positive charge. Another way that we indicate this is with this arrow. Points to where the electrons are going, and there's a little plus sign on the positive end. So carbon-oxygen double bonds are polar, but carbon-carbon double bonds, obviously, are nonpolar, because a carbon atom, two carbon atoms are the same, and they're not going to have different attraction for the electrons. Because of this double bond with the carbon, excuse me, we end up with a trigonal planar structure around this carbon atom, and that's significant in some situations. Generally, with 4 single bonds, carbon will have a tetrahedral shape. But when you get a double bond in there, now we have a total of 3 bonds and we get a tetrahedral shape. There are 5 different classes of compounds that contain this carbonyl group. We're going to talk about the first 2 in this chapter and the others in later chapters. So aldehydes. So here's the carbonyl group. In an aldehyde, we have this carbonyl carbon being attached to a hydrogen. So this is the generic functional group. Here's the simplest one, and here's a couple other examples. We've got carbon-oxygen double bond and a hydrogen on the carbon. That's what makes an aldehyde. Ketones are similar, but this carbon is bonded to 2 other carbons. So this is the simplest one, and here's a couple other examples. And we're going to talk a lot more about aldehydes and ketones. Carboxylic acids also have this carbonyl group. But now on that carbon is a hydroxyl group, and those will come in a future chapter. Esters. Esters also contain this carbonyl group. An ester is like a combination with an ether, and the name is a little bit like ether, ester and ether. We've got carbon, oxygen, carbon, but then we also have this carbonyl bond in here. And then we have amides, or amides. People pronounce it different ways. I'll probably flip back and forth because I've never decided which way I like. Amides, where we have again the carbonyl group, but this time we have an amine group, a nitrogen group attached to the carbon. So the difference between these 5 classes is what is bonded to this carbon. Is there at least 1 hydrogen? Is it 2 carbons? Is it an oxygen with a hydrogen? Is it an oxygen with another carbon? Is it a nitrogen? Just kind of a preview of what's coming up.